have stat, edit, and then we put in our 1996, 1998, 1999, 2002, 2003, 2004, 2007, 2008, 2009, then 78.04. Oh, put in the wrong column. So we have 78.04. Now, what regression is this one?
You put 2002.
Oh, cool. I'll get to that. Come on, Lepp, grab a mitt, get in the game. Thank you. I love this board. And, all right. What regression do we have to find? Do we know? Why? Why is it linear? It's true, but why? Because it asks us for the linear regression, right? So what this does is this just takes a whole bunch of data, guys, and it draws a line of best fit through it. So it's trying to get us the best fit data that fits on here. Now I want to show you when we turn the correlation coefficient on, which is B, which I told you to bypass to this point. You see B? B says you go second, and you can all follow along with me. You can go second and then 0, which is catalog. Now you have to go all the way to diagnostic on, and it's alphabetical. So hold down for a little while. Not diagnostic off. We want to put the diagnostics on, which is our correlation coefficient, which will make sense in a little bit. So diagnostic on, you hit enter, and then you have to hit enter because it has to say done. You'll see more data when you go find your equation now. So let's try it again. So how did we get the actual equation? We went stat, calc, and we picked 4, 5, or 6, right? Because that's all we have in this unit is linear, quadratic, or cubic. It said linear, so we picked linear. And then we hit enter till it calculates. Now we have more stuff in our table, right? Do you see that? There's more stuff below your equation.
How do you do the diagnostic one?
You do second, 0, second catalog. And then you go all the way down to diagnostic on. And then hit enter until it says done. So here it has an R squared. That R squared is the correlation coefficient. Is everyone paying attention? So that R squared tells you how much percent of the data that's actually in this table falls on the equation they gave us. Because they just miraculously, your calculator, say, thank you, calculator. Your calculator just took all that data and poof, it gave us a linear equation that fits best to all those points. Those are just coordinates, right, on a graph. And it drew a line of best fit. Now, does 100% of the data fall on there? No, because it's the R squared that we care about. 0.9612, da-da-da-da-da. So 96% of the data that I gave you, that we typed in, 96% of it falls on the line. 96%, that's pretty darn good. Almost all the data perfectly falls on that line. So we couldn't get a perfect line because our calculator is giving us a line of best fit. It's trying to figure out how could I draw a line to get the most amount of this points to land on a line, right? Because we picked a linear regression. So we got this, and we had y equals 0.858480263 minus 1635.732803. So it gave us all this data, right? Now it would really stink if we had to write it all out and then transport it to our y equals and type it all in, right? But we learned a way on Friday that was the fast way that our calculator will just put the regression equation in there. So when we press y equals, we're trying to get the regression equation to land in there, right? That equation that just came out is called a regression equation because this is a regression and we found a linear regression, right? So now our calculator has a linear regression just sitting in its memory. It's just sitting in the memory and it's like, put me into y equals. Like, I want to see what I look like, you know? So it's just sitting in the memory. So we want to get it to land into the y equals. We want to get that regression equation in there. Well, how can we do that? Well, we have to get regression equation in here and then we can hit enter. Well, how the heck do we get regression equation in there? Well, that was the steps that were on here for E. E was graph the regression equation. So let's get it in there, right? So we would go y equals, and then we press vars, statistics, which was number 5, and we went over to equation, because what does this say? Regression equation, right? So I'm getting the regression equation to go there without me having to write it. That's why you press vars, or statistics, over to equation, and then enter, because you're putting that regression equation, that's how to get it into y equals, right? Now before we go on and move and do anything, we have to make a window that actually fits the data. Because if we use negative 10, 10, like if I went zoom 6, don't do this, and I have a negative 10, 10 window, great. Love the line. Super pretty. I see nothing, right? So we go to our window, we change our data to fit the data that was on here. Mrs. Z talked about that on Friday. So the lowest point we have here is 1996, right? I always go quite a bit lower, so I'm going to go to 1983. That's when I was born. What does that make me this year? Quick math, quick math.
Old, baby.
Old, not 50. That is some really bad math. 40. In September, I'll be 40. Good cover, 30.
What's your birthday?
September 8th. So I'm still riding 39 train.
There's like a certain like September 13th to like 18th or 19th is the most popular birthday.
September 8th. No, I didn't hit it, I guess.
That's
Only I was born late. All right, X max. So we're 2009. What's bigger than that?
2010.
Okay, what's a bit bigger than that? We'll go 2020. Sure, we'll go 2020. The X scale you can change. It's just the number of ticks. So if I press graph, right now I have from 1983 to 2020. So like if you look, there's enough ticks I can actually see them, correct? Right? But if I go and you can't see the ticks, it's just like say you have 100, you go from 0 to 100 and you leave the scale be1, then there's 100 little ticks being drawn. It just looks like a dark black line, right? So that scale is just what those ticks are each worth. So if I went from 1 to 100, I'd probably make my X scale be 10, so that every 10 it was a tick drawn instead of just this dark black line that I can't tell what they are. The scale isn't essential to actually calculating stuff, but it is if you want to be able to see what the heck's on your graph instead of a dark black line. Okay, then I go to my Y's. What's my lowest distance I could possibly ever have if I wanted to? 0, right? So I could go a Y min is 0, because I can't have it be anything else. What would my Y max be on this one? 100? Sure. Because 90.6 was there, so I can make it be 100. Now here's where I'm going from 0 to 100 with a scale of 1. It's a pretty tiny line, right? But if I want to, I can make my Y scale be 10, and then every 10 it draws a tick, and now I actually see some ticks, right? So it's up to you with the scale what you want to do with it. So I have a graph sitting there, right? And we can get the graph to show up. Yeah?
I think I did something wrong.
Yeah, me too.
Why?
Just like it's
Check your window. Make sure your window's the same as my window. Your window is not the same as my window. Make your, well, mine's 1983 to 2020, and yours is negative 100 to 200.
So,
That's 1983. I think actually below this one. What do you know about that one? 1983. And then 2020.
I don't know, man.
0, no, that's 1. 0. Lowest distance is 0. And then that one you need to get. There you go.
It's so long.
No, that was not the same equation. We don't have the data we have. Oh. You're in the wrong place. Okay. So we wanted the linear regression equation. You should already have it written down. Did you guys all write it down on Friday on your paper? No? Okay. So let's go here. So determine the linear equation. They'll often say rounded to the nearest hundredth or something like that if they want the equation. Are we allowed to round our actual equation into our calculator though? No, that's why you transfer the stuff with the regression. So, round to the nearest hundredth is 2 decimal places. Now, you guys, if you go to type this in your calculator and you type in the rounded version instead of using the regression buttons to get it in, you will get a different answer than everyone else gets. All right? So, round to the nearest hundredth. Let's write it down. So we have stat, calc, linear, just so it shows back up again. So I have 0.86, y equals 0.86. X, 0.86, and then x, plus b. B is negative 1,635.73. Make sure you're writing this down. Now the other page I gave you is the new stuff from today. So I gave you 2 pages today. One was how to type in and get your equation to show up and graph. The other one is if I give you data and ask for information, what do I do? So this one here says, determine the world record distance for the year 2006. I need to decide, did they give me X or did they give me Y? So remember, the year is X, the distance is Y. Did they give me X or did they give me Y when they said for the year 2006? X, because the year is in the X column. So they gave me X equals 2006. Now you go to your sheet that's in front of your face. It says graph and analyze functions with graphing calculator. Here it says, if you look at D, no, C, look at C. It says determine Y when X is known. Do you see that on the sheet that I gave you? The separate sheets off to the side. You should all have the sheet out.
Yeah.
So if you look at C, it says determine Y when X is known. I'm trying to determine Y when X is 2006, so X is known, right? So how do we do that? Whenever we know X and need Y, we go second trace. And the reason why we press second trace, what word's behind trace? Calc. Every time you press second, you're getting the word behind it. So I'm trying to calculate something here, right? So go second, calc. And then here it says number 1. That's where we put X's. So if we know X's, we go second, trace number 1, and then X equals, and you just put what X equals. Now, we're trying to put in 2006. If it errors us, it's because your window doesn't actually contain 2006. Don't go out of this, I just want to show you. My window's from 1983 to 2020. Does 2006 fit in there? Yeah, so my calculator's going to be happy with me. Okay? So I go second, trace, value, and then I go 2006. And I get an answer. Now we have to go back and read our rounding rules. It says, to the nearest hundredth of a kilometer. Now, hundredth, the rounding rules is how many zeros that number has is how many decimal places you round to. So how many zeros does 100 have? 2. So how many decimal places are we going to do? 2. So here we have 86.378. So I'm going to keep the 37. When I take the 7, I look one further, it's an 8. So what does the 7 become? An 8. So we get 86.38. Now it's a word problem. Is that good enough? No, it says determine the world record distance for the year 2006. The world record distance for the year 2006 is 86.38 kilometers. So if I know an X, I just do second trace value. It says X equals, I put in the X. Get out of Y. That's it. If it errors me, it's because my window doesn't actually contain what I'm looking for. Like if I had went from 1983 to 2000 and I wanted to find 2006, it would be like no dice. It would get mad at me. Okay? So that's given x. So I know x, I'm trying to get y. Okay, paying attention. Determine the first year the distance reached over 85 kilometers. I have no idea why he's playing his movie so loud today, but I learned a lot of social today that I didn't want to. All right, distance reached over 85 kilometers. Did I give you x or y? Go back to your table. I gave you 85 kilometers. Which one of these is kilometers? Y. So this time I gave y because it's distance in kilometers. So this time I gave you y equals 85. Where's the place I can put it into y equals? Well, if I don't remember, I can go to D. D, determine x when y is known. Press y equals. Do not clear out your y equals. Everyone's paying attention. Grab your calculators. So you're going to your y equals, and you're not clearing out that one. You're not getting rid of that. That's going to be a problem. In your y2, you're going to put them out. What was it? 85. So where can I put an x? Second trace value. Where can I put in y? Y equals. I just put it into the second one. Now press graph. You have to be able to see the two graphs intersecting. If you don't, you have to change your window to see the two graphs intersecting. Because what we're going to find is where those two intersect. Okay? So we put it into y2 so that we get two graphs. And now we're going to find out where they intersect. Well, how do we do that? We want to calculate intersection, right? So we go second, calc. Which one of those is intersection? 5. And then I just go enter, enter, enter. Now this is what you have to watch. In 2004.3941, I get to 85. Can I round down to 2004? Would 2004 still give me 85? No, so I'm going to have to round up, even though rounding rules wouldn't make me round up. Because if I go to 2004, watch, second trace value, 2004. I'm at 84.66. I'm not big. It's not big enough. So if I'm rounding to the whole year, I actually have to go to 2005. Second trace value 2005. Now I'm at 85.5. It's more, but at least it's 85. Okay? So it's going to be the year 2005. Determine the first year. The first year, because in 2004 it didn't reach that, right? It says over 85 kilometers. So the first year, the distance, make sure you're using your calculator, reached over 85 kilometers. Was in 2005. Now I have to make a domain and range pertaining to the context, which means pertaining to this question. Now some people say it's linear, so it's XER, YER. No, it's a word problem. So a normal line, yes, it's XER, YER, correct? But this is not a normal line. This is years down here. And this is distance, correct? So I'm going to start at 0 on both of them, right? So if I go to my graph, I'm going to take out this red one because I don't want it in there anymore. It goes like this, right? So we need to know what this is. And what is this on the line? The y-intercept, correct? In my equation, which of these are the y-intercept? Yeah, this one's way lower, correct? It's negative 1,635. Because I didn't actually start my calculator at what? X equals 0. Could the year 0 be there? Yeah. So if we think about this one, it's in years and kilometers. What's the lowest a year can be? 0. What's the lowest a kilometer can be? 0. So you could technically go x is greater than or equal to 0 and y is greater than or equal to 0 because you can't have negatives of those. Okay? We're just discussing the domain and range. We're not writing them down. We're just showing you that in a word problem, your domain and range will change depending on what the actual time or distance is, right? Because you can't have negative distance. You can't have negative time. If we were talking about volume, volume would start at 0. You can't have negative volume, right? So then your y would have to be greater than or equal to 0. So it does change when it becomes a word problem as opposed to a graph. Okay, we're going to go to this one. What do we have to do? Go to our y equals, clear it out. Then go to our lists, clear them out. So I go to my y equals and clear it. The reason why you clear your y equals is if you forget to clear your y equals, you might do the next question with that equation. You might not actually put your regression in and just continue to do all the questions with that first equation you put in. So clear your y equals out so that you can't do that oopsie. Then we go stat, edit. Now remember, we want to clear lists. We don't want to delete lists. So we go to the top and we press clear, enter, because we want to clear the list, not delete. If you delete a list, you have to call me over because I've reset your calculator. And then we go to L1 and we go clear, enter. There will be someone who deletes their list every single semester. Do not delete, clear. What did you do? You did it? No, don't do it. It's not a challenge. Okay, so example 2, here it says, Matt buys t-shirts for a company that prints art on t-shirts and then resells them. When buying the t-shirt, the price Matt must pay is related to the size of the order. 5 of Matt's past orders are listed in the table below. Often when you buy more, things are cheaper, right? By quantity, that's just a thing. So here they want us to determine a linear regression equation to the nearest hundredth where necessary. So if it's a whole number, I don't have to go to the nearest hundredth, right? So we want a linear regression. So we go back to our calculator and we type the number of shirts in list 1 because it's X and the cost per shirts in list 2. So let's start typing. And you have it in your list. We have to calculate the regression, right? On that paper, it leads you right through the steps. So what regression are we going to find this time? Linear, quadratic, or cubic? What does it say? It says linear. So we're going to go stat, then calc. Which one? Stat, calc number what? 4, because it's linear. And then I want to calculate it. So it's either 1 enter if you're in a TI-83, or if you have a TI-84 like my screen, you have to go all the way to calculate. How much of this data fits on this line that they just gave us? My R squared is 1. Actually, 100% of my data lands on this regression. This regression line is perfect for the data. Every single point lands on it. It's pretty cool. So I got my regression equation. Cool. Now I need to write it down. So it says to the nearest hundredths where necessary. So it'd be negative 0.0 what? 7, right? This one would be y equals negative 0.07x. And then plus 6.5 because it goes in for b. Now, do I use this into my y equals? The rounded equation? Do I ever use a rounded equation? No. So my screen just got me an equation, right? It's sitting here. So my first step is to input data. My second step is to get an equation. My third step is to get that equation into my y equals, right? Without me typing it. So how do I do that? I press y equals. And now I have to somehow get regression equation to show up, right? How do I do that? I go vars, statistics, number 5. Over to equation, the EQ at the top, and what is that?
1.
Regression equation, 1. Enter. and then it shows up, right? So my first step is to put data into list. Second step is to get a regression equation. Third step is to get into y equals. And before I can do anything else, I have to do a fourth step. Does anyone remember what the fourth step is? Windows. My windows have to actually fit the data, right? Because my data is different. Let's press graph and look at it now. Okay, this data doesn't fit the window that I had before. So I go to window, and I look at my lowest x. Okay, let's look at my x's. What is my lowest x for number of shirts? 200. What's the lowest number of shirts I could buy? 0. I can't buy below 0. I can just say no thank you and buy nothing. I can't be like, I hate your shirts so badly, I'm going to unbuy shirts. Like, you can't do that. So your x minimum is 0. Perfect. Then I go to my x max. What's the highest number of shirts that's here that he bought? 740. I always go for double. So I'm going to do, double would be a little less than 1,500, right? It'd be 1,480. I'm going to do 1,500. Okay? I double. So I'm going to go to 1,500. Now, if I press graph, look at my x. It's just a solid black line, correct? It's a solid black line because for every one tick between 0 and 1,500, I have a little tick. That's what x scale of 1 means, right? So if I make my x scale of 100 instead, it'll show the ticks. Do I have to change my scale? Could you leave it at 1 and just see nothing? Sure. It's just nicer when you can actually see the ticks. Okay? But so far I've only done my x's. So let's go to my y. My y is cost per shirt. What's the lowest a shirt could cost? 0. Could it actually cost 0? Would they give you, I guess if they were giving away shirts, it cost 0. So we're going to put a 0 here. Then what is the highest cost per shirt currently? $5.20, right? So I'll double it, make it a little more. I'll make it 11. We have it at 100, which is a bit aggressive. And then now, because it's 0 to 11, I'm going to make every tick be 1, because then I'll have 11 ticks on the bottom. And I press graph. Now can I see a better line? Yeah. So you're just making your window be below the x, and just above, and like double the x, below the y, double the y, right? Because then we can actually answer some questions. Does that make sense, how to set your window? Honestly, regression windows are the easiest because you just go below the lowest and above the highest. And they give you lowest and highest. So at least you're not completely surely guessing. Okay? So let's go and answer some questions. Here it says, oh, come on. I love this calculator. And, oh, here it is. Okay. It says, Matt has misplaced the information from his supplier about price discounts on bulk orders. He would like to get the price per shirt below $1.50. So I have to discuss, did they give me X or did they give me Y? $1.50. So I go to my table. X is number of shirts. Y is cost per shirt. Did they give me X or did they give me Y?
Y.
They gave me Y. So I have y equals $1.50, and they want it to be below $1.50. So I'm going to have to round my number of t-shirts up to make sure I go below $1.50. Now they gave me y. Where do I put y if they give me y?
Y.
Into y. Yeah, that's it. It goes into my y2. Please don't delete out your y1. You're going to have to go through all of the work again. So it goes into your y2, and it's $1.50. Now I hope to see them cross, right? If my calculator cannot see where they intersect, my calculator cannot calculate where they intersect. So if you see that you can't see the intersection, you might need to make your x max bigger to actually see where they cross. Your calculator can't calculate what it can't see. So now what are we going to do to find out where they intersect? Second, trace, which one? 5. Intersect's awesome because I can just go enter, enter, enter. And now that's 769 shirts. How many do I actually have to purchase to get below $1.50? 770. Because if I went to 769 shirts, the price wouldn't be below. If you don't know, do this. You can always go second trace value, 769. That is not 769. 769. And the price per shirt's $1.50 in a little bit. Right? So then I say second trace value 770. Oh, it's a little bit below, right? So you can test it. You can take your x value and see what y would go with it if you're not convinced as to which way you should go. So it's 770. We can't just do that as our answer. It says how many shirts does he need to buy to get the price of the shirt below $1.50? Matt needs to buy 770 shirts to get the price per shirt below $1.50. Now if we did our domain and range again, our domain is our x values, it's number of shirts. What's the lowest number of shirts you could buy? 0, right? So our domain would be x such that x has to be greater than or equal to 0. X is the noun of the reals. Because the number of shirts you can buy is nothing. What about your range? What's the lowest you could spend on a shirt? 0. So our range would be y such that y is greater than or equal to 0. Y is noun of the reals. So the next two are linears. We're going to skip those. We're going to go to number 5, which is a quadratic. So turn to example 5. What's the difference if it wants you to find a quadratic regression? What's the only difference we're going to do? Press quadratic. That's it. Okay? So we're going to be on example 5. Of it. Example 5 is the very bottom of this page. So time still, list 1. The ones without decimals for sure always list 1. Then y is list 2. This one here is Josie hit a golf ball from the top of the hill. The height of the ball above the green is given in this table. So I hit a golf ball from a hill and then it lands, right? So it's doing the parabolic shape. That's why it's quadratic. So you try and get the equation and write it out. Because it says here, determine the equation of the quadratic regression function to the nearest hundredth where necessary. So if there's whole numbers, you don't round. So go get the quadratic regression. So if we go and put the data in, we would get this time. So y equals, I would clear them both out. Then I go to stat, edit, clear the list. And then I would go 1, 2, 3, 4, 5. Then here I would go 52.5, 73.2, 74.6, 55.8. Wait a second, it's going down. How is it going below 52.5 if initially? At 1 second it was at 52.5. How is at 5 it's at 16.1? Yeah. We're also hitting it off of a what? Where are we hitting the ball off of? A hill, right? So we're assuming that this ball isn't landing back on the hill. It must be hit off the hill and then actually goes over past the hill and then lands like to the ground level, right? Below. Like sometimes they're on a cliff and they throw a ball off a cliff or a rock off a cliff and then the rock goes up a bit and then lands way lower, right? Because it gets to ground level. Okay, so then we'd have to go stat, calc, and it tells us a quadratic regression. So we go to 5, we hit enter. Now it sets the nearest hundredth where necessary. So this negative 10 is going to go in for A, 51 point whatever is going to go in for B, and 11 is going to go in for C. So we're going to get y equals negative 10.07 x squared. And then nearest hundredth is 2 decimal places, so it's 51.41, and then x. And then plus 11. And we don't put that into our y equals, we put the actual whole thing into our y equals, right? So we go to our y equals, and we go bars, statistics, over to equation, enter. Does everyone have that? Okay. Then what do we always have to do before we answer any questions? Make a proper window. So I go to my window, and it's at 0, 1500, which is aggressive, because this is at 5. So I'm going to go 0 and 10. Go up by 1 maybe. And then this one, 0 would be ground level, and the highest this goes to is 74.6, so I'm going to do 85. That's just a random guess. I press graph, and I have a graph in front of me, right? Okay. So this one here says, use the equation above to determine the height of the ball at 2.5 seconds. So I go to my table, 2.5 seconds, which is time, x or y? X. So I gave you x, right? So this is x equals 2.5. Where do I put x equals in? Well, I go second, trace, value. That's when x equals. So I go 2.5, and I get 76.575. So I'm going to say 77. 77. You couldn't get in trouble for rounding wrong because I didn't give you any rounding rules, right? Yep. So 77 meters. Then 4.5 seconds is still time. So I put in for x. So I do second, trace, value, 4.5. And it's lower, right? Because the hill is like at 11. And it goes up and then back down. So that would be 38 meters. The next one says, when did the ball hit the ground? What is the ground? Height of what? 0. Is that not a y? The ground is a fancy way of saying height equals 0 meters. So that's a y, isn't it? So can't I make my y2 then just be 0 and find out where they intersect? It's just a fancy way of giving you a y. It's just giving you a y that's 0. So I go to my calculator, and I go to my y2, and I put in a 0. Now, if you are using not a calculator, remember you can go over here and make it thicker, right? Hit enter, make it thicker. So we'll press graph, and now we want to find out where it hits the ground. So I have two equations, so I go second, trace, 5, and I go over near where it's intersecting, and I go enter, enter, enter. 5.31. So 5.31 seconds. And then you'd say, when did the ball hit the ground? The ball hit the ground at 5.31 seconds. What time does the ball reach a height of 60 meters? So, did they give me x or y? Height. So now we have y2 is 60. Because they gave us a new height. So I go to my y2, bless you, take out this one, here, and I put in 60. Wait, there's 2. Why is there 2? Goes up past 60, reaches its maximum, comes down past 60 again on the way down, right? So there's going to be 2 times. Everyone paying attention and trying this? So we do second, trace, 5, and we go close to, I arrowed up to the flat line. We need to go close to the first intersection. As long as we're close to it, we go enter, enter, enter. And I get 1.27 seconds. So 1.27 seconds is the first time it reaches 60, right? So that's my first one. If I just go second, trace, 5, enter, 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 enter again, I get 1.27. Keeps finding the same spot, same spot, same spot, right? So when I go to do it again, I have to go second, trace, 5, and move over to the other intersection. Get close to it. And then I go enter, enter, enter. So you have to actually move it, or it'll just keep intersecting at the same spot over and over and over. Okay? So that's 3.84 seconds. So these are the 2 times. The next one says, what is the maximum height? Maximum is the giveaway. You have to find the maximum, so the highest spot it goes. How do we find a maximum? Well, I'm going to go here and clear out my 60 because it's going to annoy me just seeing it in there. So I want to find the maximum of that graph. How do I calculate a maximum? Second trace, because that's calc, right? Second trace, and which one am I going to pick? 4, because it says maximum. Now, what does it say on my screen? It says left bound. So I need to be on the left bound of whatever I'm looking for. So I need to be on the left side of the maximum. Here's my maximum. I need to get onto the left of it. Anywhere on that left. Hit enter. Then it says right bound. So now I need to be on anywhere on the right. Enter, enter. And I get 2.55 and 76.60. Which of those is height? The x or the y? Y is height, this whole question, right? So y is height. So this is the time it reaches maximum. This is the height at maximum height. They'll often ask for both, or they'll ask for, sometimes they'll just ask for what's the time it reaches its maximum height. And people will give me 76.6. No, the time it reaches its maximum height is 2.55 seconds. This is time, this is height. If you can't remember, go to your table, x, y, right? So this one here says, what is the maximum height? So it's 76.6 meters. And you write a sentence. And then here it says, at what time does the ball reach maximum height? What time did it reach the maximum height? 2.55 seconds. The x. What is the height of the ball at the moment of release? Moment of release means time equals what? What does moment of release mean? Time equals what? When I go to throw the ball, what time is it?
0.
0. So they're really just asking you for the y-intercept. Wait a second. Time is what? Is time x or y? X. So they're literally just telling me x equals 0, find y. Where can I input x's? Second trace value. Second trace value. X equals 0. Y is 11. Which makes sense, because if you look up at this, what is the constant? What did Mrs. E teach you the What did Mrs. E teach you the constant was? The constant is always just the what? The y-intercept. So you already knew that the y-intercept, the moment of release, was 11. Because it was up there, right? So that 11 is your y-intercept. So here, 11 meters. Domain and range, we're not going to worry about at this very moment. But if you look, the domain is between 0 and 5 point, whatever this x-intercept was, 5.33 or something? I don't know what it was. And then my range is between 0 and, what was the highest I got to? 76.6, right? So your range is between 0 and 76.6. Your domain is between 0 and 5.31, where your x-intercept was. All right. For tomorrow, this is what I need you to... Lord, I hate you so much. Okay, you're doing example. Circle these because these are your homework. Example 6, I need to get to so I can show you how to. Now it decides to join us. So example 6, people think list 1, 2, 3, and 4. Not true. What is this called? Years after 1979. What is this called? Years after 1979. They just saved paper. This here, just this hole, these two, just fit directly under here. But they put them side by side so they didn't have to make a really long table and save paper. I just gave this example so that if you see it on a diploma, you don't go list 1, 2, 3, 4 and then get mad at me and say, Mrs. Lepp never taught me this. This is stupid and I hate her. That would be the last thing I'd want. So, I'm showing you one. This has the same titles, right? So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 14, 17, 20. Do you see how it just carries on? And then these are the Y's. So I want you to do example 6 for homework. Example 6 is a what? What kind of regression is it? Cubic, because it says that. Example 7 I want you to do. What type of regression is it? It's a cubic. And I want you to do, so I want you to do 6, 7, and 9. 6, 7, and 9. Watch with 9. What is 9? Quadratic. So you have pick number 5. The other two you have pick number 6.